Hey, what's up everybody? Back today with a tutorial that's been requested quite a lot for a long time, and I've just not been able to get it to work until recently. And that is creating a character that can move around a planet. So I'm going to show you guys how to do that today. This is just the most basic version, single planet, and I'll do follow-up tutorials with multiple planets and so on and so forth at a later time. Today, just setting up the character and the camera and the planet object. Alright, so let's go ahead and jump right into it. And the first thing I'm going to do, actually, before that, is delete out the audio so that when we play, you guys don't have to listen to the birds. Okay, so let's go ahead and get started. So I already have a whole bunch of template things so that I can go and check if I need to, but hopefully I won't need to do that too much. The first thing we need to do, I just created a tutorial folder to put all this in. And the first thing we need to do is go ahead and create a game mode. We'll call this game mode. Let's go ahead and call it tutorial game mode. And here we're going to go ahead and switch this over to the tutorial game mode. Okay. And now that we've done that, when I hit play, it just puts you into the spectator pawn because we don't have a default pawn. So we're going to go ahead and create a tutorial pawn. So let's go ahead and create a blueprint. And it's going to be a pawn. Now I tried to do this with a character and use all the character controls and force and movement and stuff like that, and I could just never get it working, and the rotation was always a little bit weird, and I'm not sure what's going on under the hood with the character, but it's something different than with a pawn. So I'm just going to use a pawn. I'll call this tutorial pawn. And this is a physics-based movement system, which has its pros and cons, as I'm sure you all are aware. Animations might be a little bit tricky in places, but interactions with physics objects are going to be really nice and just work like you would expect them. So there's the pawn. We're going to also want an actor blueprint that is, I'll rename this. Well, let me rename it. There we go. Tutorial planet. Okay. So now we have a tutorial planet and a tutorial pawn. And then we're also going to need a material. And the only reason that we need this material is that because this is a physics-based movement system, when the pawn is colliding with the planet, it has a lot of friction, so cause. Can't type today. So what we're going to do is we're going to create a physics material for this material. We'll call this tutorial phys mat, and we're going to assign it to this tutorial phys mat. And then we'll go ahead and do a vector parameter here, and we'll just make it some, I don't know, some gray color. Apply. And what we want basically is we want it to have a lot less friction, like 0.2, and we want it to use the minimum method. If you haven't seen this before, I have a tutorial on physics materials. Go check that out on the channel. But basically what that's doing is it's saying, hey, give this material low physics, and when you calculate the physics, use the lower of the two. So we'll use this number. That way when you collide with the surface, you actually slide along it rather than getting stuck. Okay, that's all out of the way. We have everything that we need here to do this. So let's go ahead and jump straight into the tutorial planet. So this is not a tutorial planet, that's the template planet. So let's go ahead and put a tutorial planet out into the world. And right now you can tell it just has a scene root, and we don't want that. So let's go ahead and jump right in. I'm going to add a component, and we're going to get a mesh, just a static mesh. And we're going to call this planet mesh. And we're going to go ahead and make it the root. We don't need anything else. And we're going to just go ahead and get sphere. I think that the sphere that has the best collision is this material sphere here. Could be wrong. Some of the spheres have better and worse collisions, but it doesn't matter. Eventually what you want to do is get a static mesh that has a really high collision, high poly collision mesh around it, or use complex collisions. But for our purposes, this will work fine. So there we go. We've got our little planetoid, and now we can jump straight into our pawn and start putting in code. Now, I put a whole bunch of inputs in already. And I'll go ahead and look at those just so you can see them all next to each other. But they're pretty basically set up. You have all of your axis mappings, and I realize they're axis mappings on the keyboard, but I like setting them up as axis mappings in case I want to set up controller support later. And then jump as an action mapping. Yep. So let's go ahead and jump in here, and we're going to add a mesh to this pawn. Static mesh. We'll call it mesh. We're going to make it the root again, and we're going to do capsule. We'll use the narrow capsule. So now we've got this. This is basically what our pawn is going to be, and I like to add mesh, a nose, just so I can kind of see which way is forward. And we'll do cube. We'll do, I don't know, something like that, and probably make it like 0.2, 0.2, 0.2. Do that. Make it look like he's got, like, I don't know, VR goggles on or something. That's what I did with the last one, so I'm just going to do it with this one too. Alright, and then not on the nose, but on the mesh, we need a spring arm for the camera, of course. No, did not want to do that. Spring arm for the camera. We'll go ahead and lift this up and give it a little bit of rotation, maybe 10 degrees to start with. And on the spring arm, we want a camera. Oop. There we go. So now we've got our pawn set up with a camera and a spring arm, and we need to go into our game mode and set that pawn. Tutorial pawn. There we go. So now that we've got our pawn set, when we hit play, we should, yep, there we are. We're looking at our pawn. Now, of course, we can't move, and it's not moving or anything like that. So let's go ahead and set up the control of the pawn. So let's go ahead and create a little comment box here. We'll just call this inputs, just to keep organized. We'll do right. Now these are just the axis mappings that we had set up earlier. And we'll do camera right. We'll do camera up. Yeah, there we go. And we'll do jump. Okay. So now we have all of our axis and our one action mappings out. Let's go ahead and hook them up. So what do we want to do? Because we don't know where the pawn's going to be rotationally. It could be upside down in world space. It could be sidewards. What are we going to do when we have a rightward action? Well, what we want to do is we want to take the mesh and get its right vector. Get right vector. And then we're going to multiply by a float. And we'll just use the axis value itself. And now I know this is going to be a little bit low, so let's go ahead and multiply by a float again. And we're going to promote this to a variable and call it acceleration. All right. So now we've got a vector here that's based on the right vector, but it's multiplied by an acceleration factor and then scaled based on the axis input here. And we're going to set physics linear velocity. There we go. And we'll do this. Boop. And basically we want to do the same thing for the forward, except for instead of getting the right vector, we're going to get the forward vector. Just like that. And scaled times this axis value. And then what we want to do is for the camera right, we want to get the mesh here. Add, no, we don't want to do it. Yeah, this will work. Add local rotation. And the local rotation we want to add for the right camera movement, so that's moving the mouse left and right, so you should spin around, should be around the z-axis, which goes straight up and down. So what we'll do is we will we can't just type it in here because we want it to scale based on its axis value. So we'll go ahead and make a rotator, and then we're just going to dump this straight into there. We need to hook up our pins. There we go. Now this one's a little bit different because we don't want to rotate the mesh, which is the root. So you could use an actor local rotation here and it would work as well because the mesh is the root of this actor. So when this mesh moves, the actor rotates. So either way is fine. In fact, it's actually a little bit cleaner to do that. So we'll just do it that way. Actor local rotation. One less node. Don't have to get the mesh. But in this case, we do want to rotate something, and that is the spring arm. And again, we're going to... Hang on, my headset is automatically shutting off on me. Stop that. Okay. Make rotator. Sorry about that, guys. And we're going to go ahead and hook it up. And in this case, it's we want to rotate around the pitch. So we're going to dump the axis value straight into there. So now we should have moving... I think that's all right. I'm not going to add jump quite yet. Well, you know, heck, why not? Let's add it. So in both of these, we want to add to current. That's the other thing I forgot to do. When we press here, we'll go ahead and get up vector, whatever that may be at any given time. And we're going to go ahead and multiply. And I had to experiment around with this to get the right value, and you'll have to do your own, but I think it was 1500, which seems rather high, but that's what it was. So now we'll be floating, mesh, we need to actually turn on physics and turn off gravity so that all of this will actually function. And then we should have, I can't tell if I'm moving. Well, that worked. Let's see. Let's start down here. Oh, acceleration is set to 0 because when I compiled, it automatically starts it at 0 instead of a reasonable number like 1. Okay, so now when I move around, you can see it moves, and it moves relative to your rotation, which of course right now is only being changed on the yaw. But that's everything we need to get going. Let's go ahead and make this planet a little bit bigger I don't know, because we can make it about that big. But this will work. You'll see this will work for virtually any size thing. So the next thing we need to do is go ahead and make the actor rotate towards the planet at any given time. Now I'm going to use event tick. Again, event tick is not great, but to make it run smoothly, I've had to do that. There's ways to get around this, and maybe I'll put out a video on how to do that, but for expediency's sake, we will just do this for now. So, on every event tick, we're going to set actor rotation. What are we going to set it to, you might ask? Well, we are going to make a rotation from Z and X. Now, what does this mean? Well, let's see what the tooltip says to see if this is helpful at all. No tooltip. Okay. What it's going to do is it's going to make a rotation that uses primarily a Z value that you give it, i.e. an up and down vector, a vector that you want to set its up vector to. And then it's also going to try to do its best to make X the forward vector that you want, whatever vector you feed it. However, this will take precedence over this. So it's important that you make the rotator from Z and X because we care more about being upright than we do about facing forward. It will do weird things if you do the from X and Z. So what is the up and down that we want? Well, we need to get a planet. So let's go ahead and start by getting all actors of class, and for now, since we only have one in there, we don't need to figure out what's the nearest one or anything like that. We will just get 0. Index 0 is the first one, it's the only one, and we're going to promote it to a variable that we call planet. And this is tutorial planet. So we're going to get all of the actors of class, i.e. 1, right now. And since we only have one, we're going to get it and we're going to set planet to it. Now, we have a planet, so we know the object that we want to rotate up and down towards. So let's go ahead and get actor location. What we're going to do to figure out our z-axis that we want to make the z-axis of our pawn is we're going to look at rotation, starting with the planet and looking at actor location, us, our object here, and then we need a vector, so we're going to get the forward vector. So this is the vector that if you're looking at the planet, from the planet at our actor is in front of you, and we're going to make that our z. So basically if you're laying with your back on the planet looking up at the pawn straight above you, the way that you're looking is the line that we want to set our z. Now it is the planet start and actor target. I'm not sure why that is. I'm sure there's a very rational explanation somewhere in the maths, but I'm not going to work it out. And what do we want to set the x? Well, basically we want to keep the pawn facing forward as much as possible, except for that you're rotating around the planet. So we're going to go ahead and get forward vector. We're just going to say, hey, whatever this forward vector is, keep it the same. Now it won't be exactly the same because we're yanking its z around, so as you move forward, your forward vector is going to be pulled down, and as you move backwards, it's going to be rotated. So it's going to change a little bit, and it says that here. It says x may be changed minimally to enforce orthogonality, which basically says, hey, we're going to make the z happen here, and we're going to do what we need to with the x to make the z happen, but we'll keep the x as close as we can. And that should do it for rotation. So now when we start, if we play, we should go, oh hey, there's a planet down there. And if I rotate around, you notice that the planet always stays below us. So now we have a problem. We're just flying off. So we're going to add very simple gravity. I'm not going to do the whole gravity that I did in my previous tutorial that's properly scaled by distance and so on and so forth. For this, for our purposes here, it's enough to just set physics linear velocity to this. So this is the line that we care about again for the up and down, and we're going to multiply because we want it to go, we want gravity to go the opposite way that you're looking up, right? So times -1, the opposite of the up vector that we care about, and dump that into there. And we're going to do that, and we do want it to add because this is, oh, and we also want it to be multiplied by acceleration. Now this can change if you want low gravity, different gravity, gravity that differs based on the radius of the planet, or if you put a mass system in, it can change. For now, we're just going to do straight up, always accelerates the same based on that acceleration value. Here we go. Yeah. Boom. We're on the surface of the planet, and we're looking around. And if I jump, holy moly, that's quite a jump. But what's going on? We're spinning around like crazy here. You're a physics object, so you have a lot of angular momentum that picks up, especially with the physics of that rotation getting added and added and added. So what we're going to do is just, we don't need this because we're manually setting the rotation each frame. We're just going to set this to something like absurdly high. And I also find it helps if this is set to something like 0.3, the linear damping. All right, so now this, but it kind of is tough to move. So what we want to do is come in here to the mesh, and we're going to use the tutorial material, which again has a low friction, lower than the 0.7 that's standard. So now you move smoothly around. I can look around. Now, of course, I haven't clamped speed, and I haven't clamped the rotation of the spring arm here. So we can do those things. But this is the basics. This works. I can jump. That's a heck of a jump. Maybe I should set that down to something like, I don't know, like 400. Maybe it was 150 is what I figured out was a good one. Maybe I was off by an order of magnitude. Let's see. No, that's a little weak. Whatever. Anyway, so you can jump, you can do all the things that you want, and the camera just works. It stays where it should. I hope this is helpful. Let's go ahead and make this really, really small just for fun. Some like Super Mario Galaxy stuff going on here, huh? Hope this was helpful. Let me know in the comments if you want a little bit more information on this. I'm going to do some follow-up tutorials. I'm going to do moving planets. I'm going to talk about some of the issues that I run into with moving planets. I'll add planetary rotation. I'll talk about some things like that in future tutorials. If people want me to, just let me know in the comments. And like and subscribe if you think that this video deserves a like and subscribe. Have a good one, guys.